In this section, we're going to talk about hyperbolas, and then we are going to do a little more about looking at equations of conic sections and determining what shape we're looking at. Hyperbolas are given as the difference in the distance between two foci, each individual focus. This is a focus here, and this is a focus down here. And if I take the difference in the distance between this focus and a point on my hyperbola and this one, no matter where I pick a point, that difference is always the same. So for a hyperbola, I've got two foci. I have two vertices. Both of these are considered vertices. And I have a center. This distance between the two vertices is known as the transverse axis, and we talk about whether that's vertical or horizontal. In this case, this is vertical. The equations for hyperbolas, if they are horizontal, the transverse axis is horizontal, so not like this one, is x minus h squared over a squared minus 1 minus k squared over b squared is equal to 1. And notice something. This is horizontal. As a transverse axis that's horizontal, the negative here is in front of the y squared. Alright? Well, if it's vertical, if it looks like the picture I've drawn here, then my equation is y minus k squared over a squared minus x minus h squared over b squared is equal to 1. Now notice here, it's vertical. This minus sign is in front of the x. So that's going to tell you whether this is vertical or horizontal. The center is going to be hk, regardless of how you set up the equation. The vertices for your hyperbola are a units from the center. So whatever a is, if you're going vertically, you're going to go up and down. If you're going horizontally, you're going to go left and right a units. The foci are c units from the center. And we can relate a, b, and c with c squared is equal to a squared plus b squared. Notice that's a plus when we're talking about hyperbolas. There's one other thing in here that I want to mention, and we're going to spend a lot of time on it, but notice that there are two asymptotes that approach but never quite get to these two parabola-looking things on a hyperbola. If I take my a value here, this would be a, this would be a, and I come this direction to b and b, then I end up with basically a little box here. And if I connect the corners of that box, it gives me an asymptote or an asymptote going each direction that approaches it but never quite gets there. There is a way to find the equation for those asymptotes. If it is horizontal, the equations for those two lines are found by taking y equals k, that's the y value in the vertex, plus or minus b over a times x minus h. It's just going to give you equations for two lines. If it's vertical, like the one I just drew, then the only thing that changes, it's still y equals k plus or minus, but we reverse our a and b, a over b, x minus h. If you need the equations for those two asymptotes. Okay, well, let's look at a problem with this and look at how to actually find the center, find the foci on a hyperbola. If I'm looking for the center of the foci for y minus 4 squared over 16 minus x plus 2 squared over 9 is equal to 1. Well, first of all, is this going to be a horizontal or is this going to be a vertical hyperbola? Well, which one's negative? Well, it's the x squared that's negative, which means that this is a vertical hyperbola. So the center here, really easy to find. The center is at 4, -2. It is at HK. The foci can be found by taking A and B, and I'm going to say C squared is equal to 16 plus 9. I'm going to add them together. That gives me 25. So C must be equal to 5. Well, this is a vertical hyperbola. So I need to go up and down from the center. The center was at 4, -2. So I'm going to go up 5. Well, if I go up 5, I get the point 43. And I'm going to go down 5, and I get the point 4, -7. That gives me the foci of my hyperbola. All right, one more thing in this lesson that you might find helpful. In 9.1, I talked about how you could tell if a particular equation gave you the equation of a circle, a parabola, an ellipse, or a hyperbola. Well, there is another way to do it besides the way I listed. And it's really the same thing, it's just a different way of stating it. If this is in general form, we can do just about anything with an equation of this form. General form of any conic section. Ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Well, the important things here are the x squared term and the y squared term. If this is a circle, A is equal to C. It's that simple. A is equal to C. If it's a parabola, then AC is equal to 0. Now, let's refer back to what we did a minute ago. We said that if it was a circle, x and y were both squared and they had the same coefficient. All right, which means A is equal to C. What does it mean here? Well, a parabola only occurs if you have either x squared or y squared, not both, which means one of these two terms is 0. So when you multiply them together, you get 0. So if you say A times C is equal to 0, you know that you've got a parabola. Well, on an ellipse, we said that happened when x was squared, y was squared, but they didn't have the same coefficient, but they did have the same sign. Well, we can also say that as AC is equal to 0. Greater than 0. Well, why? Well, if A and C are the same, we would have already said it was a circle. But if I multiply them together, A times C, and I get a positive number, then either A and C were both positive or A and C were both negative. They have the same sign. So I've got x squared and y squared, they both have the same sign. Well, with a hyperbola, AC is less than 0. Well, that should make logical sense here. A and C, they're not the same. If they were the same, we wouldn't have a circle. They're not equal to 0 because they don't have a parabola. If I multiply them together and I get a negative number, that means that one of these is positive and one of these is negative. They're both squared, but one of them has a coefficient that's a positive number, and the other one has a coefficient that's a negative number. So this is just another way to classify conics if those conics are in general form. Probably will find this helpful when you get ready to do your review and your quiz for this section.